All right. So slope-intercept form and standard form. First of all, the little sentence at the top here, linear equations are frequently written in slope-intercept form. I just want to remind you, I mentioned this on, I think, Monday, that when we're talking about something called linear, we're talking about a line. And in math, a line is what we would all consider to be a straight line. Lines in a math class cannot have any sort of curve or change of direction. They are perfectly straight lines, moving in an upward direction, a downward direction, or side to side. Perhaps they're vertical. Linear equations mean that you wind up with a perfectly straight line on a graph. And it says they are frequently written in slope-intercept form. I would actually say it's more than frequent. I would say it's by far the most common form of an equation that you will see to represent a straight line on a graph. There are 3 different types of equations that we're going to see for straight lines on a graph, but slope-intercept form is by far the most useful one, and it's the one that you will use the most. We will see the other 2 types. We will use the other 2 types, but primarily in this class, in geometry, in algebra 2, slope-intercept form is by far the most common usage for a linear equation. And we saw this briefly yesterday in that little online module we did. And the slope-intercept form of an equation says that y is equal to, and I'm going to use colors again because I always feel like it's nice to break it up that way. Y is equal to, let's see, m for the slope, and then x plus b. So y equals mx plus b. This is something that I'm sure many of you have seen before and probably have used before. And that's our slope-intercept equation. I'm going to write down what m is equal to, what b is equal to. We'll talk about this equation a little bit, and I'll reference it in context with what we did yesterday. And then we're just going to go through the rest of this notes, page 1 and 2, and we'll be done with it. And it will be, I think it'll be pretty quick. So m, what letter do we use for m? We've dealt with this for a few days already. What do we say for m? What does m represent? The slope. Yep. This is the slope. The rise over run, the change in y over the change in x. We write it as a fraction. So whatever m is going to be a fraction. We're going to replace the letter m with whatever fraction number we get for our slope. And then b, does anybody know what b is on this? I'll give you a hint. It's on the next sentence where it says directions. Yeah, the Y-intercept, exactly. And I think I mentioned it yesterday, but does anybody know what the Y-intercept is? So the slope is the steepness of the line, right? It tells us if it's going in an up, or down, or horizontal, or vertical. That's actually really, really close. And I think I know what you're trying to say. Ash, what do you think? Yeah.
It's basically where
kind of. If you think of the starting point as the point on the y-axis, I would say yes to that. And Creighton, you were also mentioning kind of the y-axis as well, which is exactly what it has to do with. It's the, so I'm just going to do a little arrow here, and I'd like you to write this down. It's, so where the line crosses the y-axis. So whatever point that the line crosses the y-axis, that's the number for the y-intercept. It's the y-coordinate for that. And I'll just give you a quick example here about how that might look on a graph, because the first 6 problems, they tell us what the slope is and what the y-intercept is. And the ones after that, you're actually going to start seeing some graphs. So go ahead and write this down. So the y-intercept, that's where the line crosses the y-axis. That's always a nice thing to know what that actually means. I think a lot of times y-intercept is sort of assumed people know what that means. And I'm going to point it out to you on the actual graph as well as we go through this. So every single one of our examples, go ahead and grab one of each of those. Every single one of our graph examples has 2 points. You might notice that as you look through those notes. In addition to that, one of the 2 points is the y-intercept. And it's the point that's on the y-axis. So for example, if we go down to number 7 real quick, the y-intercept on number 7 is the y-coordinate of this point right here. So that would have a y-intercept of 1, 2, 3, -4, because it's down 4 from the x-axis and it's on the y-axis. So -4 would be the y-intercept of the graph of number 7. On number 8, it's up here on the y-axis. So that would be up at 1, 2, 3, 4, 5, 6, 7. So that would be a y-intercept of 7 on this particular graph here on number 8. So anytime you're trying to find a y-intercept, you're just finding out exactly where that line crosses the y-axis, either up or down. If it's up, it's a positive. If it's down, it's a negative. So what we're going to do first is we are going to write each of these equations in slope-intercept form, given the slope and the y-intercept. All this means is that we are going to substitute in, on number 1, we're going to substitute in the number 2 for m into this formula, and we're going to substitute -1 in for b on this formula, and that's it. X and y remain x and y when we write these equations. X and y represent any possible x or y coordinate, and so when we write the general formula or the general equation for a line, we don't use any numbers for x and y, at least not to begin with. We will eventually get to plug in numbers for x and y, but we're not going to do that today. So we're just going to leave these as x and y, which is why I left them black. The only numbers we are plugging in here are numbers for m, the slope, and b, the y-intercept. So for problem number 1, we've got our slope of 2 and our y-intercept of -1. And so all we have to do is replace m with 2 and replace b with -1 and just write the rest of the equation. So we're going to say y is equal to, slope is 2, so that's 2, and then x plus -1. And that's it. So you're just swapping out m with the slope and you're swapping out b with the y-intercept. Now, you will see it written like this occasionally. However, I'm going to say or y equals 2x minus 1. This is going to be more common. You're usually not going to see a plus and negative. You'll usually just see minus. Plus and negative and minus mean the exact same thing mathematically. So chances are this is the one that you will see when you are presented with an actual equation. When it gives you the equation and it say, once you graph the equation, it'll look like this. And so you'd say, all right, my slope is 2 and my y-intercept is -1. If this is a plus and it's just a number after that, that means that the y-intercept is a positive number. So like on this next one, we've got a slope of -3/5 or -3/5. We have a y-intercept of 4. So we are going to write y equals -3/5. X, don't forget the x. And then plus 4. And this time I left the number by itself just red because the plus is just part of this formula up here. And since it's a positive number, we don't need to change the color of that if you're using colors. But if it's a negative number, we want to include that negative as part of the color because that negative was the y-intercept. So we're just replacing those letters with the numbers that they are equal to. Any questions so far? It's just a straight swap. Yeah. This Eddie.
If I prefer, since slope is a rise over run.
Yes.
With whole numbers.
Yes.
It's okay if we
Ooh.
write it with a 1.
Yeah, absolutely. And I've even mentioned that multiple times already. Yeah. Thank you for bringing that up. So this one here, 2 over 1. I agree. Yeah. Writing that as a 2 over 1, because when you have a whole number, thank you for reminding me of that. When you have a whole number, you can write that as a fraction with a denominator of 1. And we did see that yesterday on that little interactive thing. Every single time something could have been a whole number, it was always written as a fraction. Because when we end up graphing these, and I think we're going to graph these starting on, looks like Monday. When we start graphing these, it's going to be really important to write your whole numbers with a denominator of 1 to make sure that you include the run when there's a whole number with a rise. And I'll explain all that on Monday, but having a denominator of 1, getting in the habit of doing that with whole numbers, yes, 100% agree with that. Thank you. So just put a little 2 over 1 in this circle 1, because that one's the one that's going to be the most useful. All right, let's try. And by the way, if your y-intercept is a whole number, just leave it as a whole number. We don't need to worry about the fraction for that one because we're not figuring out a rise over run with the y-intercept. We're only doing that with the slope. Number 3, we've got a slope of -3 and a y-intercept of 2. So take a few seconds, write the equation as you think it should be written. And then I'm going to ask for somebody to volunteer their answer. Yeah, fantastic. All right, does anybody have something on their paper that they would like to share? Great, what do you got? Yeah, y equals -3x plus 2. Nice. And I'm going to write it as -3 over 1x. But if you write -3x, that is 100% correct. So there we go. Y equals -3x plus 2. That's it. So you're just replacing the slope m with the number for the slope, and you're replacing the letter b with the number for the y-intercept. That's all we're doing there. So I'm going to say, let's just say like a minute and a half. So at 8:20, we'll check in on these next 3. So do 4, 5, and 6 on your own and write those 3 equations. And then we'll check in on them at 8:20. So for number 4, we're looking at a slope of -1, a y-intercept of 7. So I'm going to write y equals -1 over 1 plus 7. Oops, -1 over 1x plus 7. Don't forget the x. Always include x. If you have just -1x plus 7, that is totally fine. Good morning. Take one of each of those. Yep, thanks. Okay. Number 5, we've got y equals 1 over 4x, or 1/4 x plus 0. Did anybody write anything different for this one? Do you suppose there might be another way of writing this one? And I'm only asking that because, yes, there is another way of writing this one. Do what? Yeah, just get rid of the 0 because plus 0 doesn't change anything. So we could just write y equals -1 over 4x. I would not necessarily recommend one or the other here. If I were to lean one way or the other, I would actually probably say go with the first one. Just because you know what the y-intercept is on this one, it gives you the number. Whereas this one, there's no y-intercept listed. So some people might be like, well, what's the y-intercept if there isn't one there? So it might be better just to use this. Yes. Oh, you're right. It was. I wrote it correctly on the left-hand side. 1/4 x. Thank you. And then for number 6, we've got y equals -5 over 2x minus 3. So we're just swapping out the slope, swapping out m for the slope, b for the y-intercept number, and that's it. So if it tells you what the slope and the y-intercept are, all you have to do is use that formula and replace those two letters with the numbers that they are equal to. Any questions on those before we look at 7 through 16? All right, so now we're going to kind of switch gears. We're going to be writing our equations based off of some graphs. So I actually usually start with the y-intercept when I'm looking at a graph, and then I figure out the slope, even though they're written in the different order here. It doesn't really matter which one you figure out first. The reason I usually go for the y-intercept is because that one is usually quicker to spot. It's just the point where this line crosses the y-axis. And I think we mentioned this a little bit earlier. This one is at 1, 2, 3, -4. So B is -4 because it's down a little ways. And then the slope here, does anybody know what the slope of this line is? This is from what we did on Monday, rise over run from a graph. What is our slope here? Okay. Well, let me ask you this question. To get from this point to this point, remember, we always go left to right. So to go from that point to that point, how far straight up do we have to go first? How far up is that? 3. Since we're going up, it's plus, +3 plus 3. How far over are we going once we get up there? Just 1, so +1. So a rise of 3, green's not showing up very nicely, and then a run of 1 gives us a slope of 3 over 1. So we have a slope of 3 over 1, and we have a y-intercept of -4. So we're going to write our equation as y equals 3 over 1x minus 4. Because once you have the slope and the y-intercept, we're doing exactly what we did on 1 through 6. So you figure out where the y-intercept is, you figure out the slope using what we used on Monday, which is the graph for the rise over run, and then plug into m and b just like we did on problems 1 through 6. Let's try number 8. What is our y-intercept on number 8? You can tell me that. Where does the line cross the y-axis? This point up here. How high up is this point? Anybody? How high up is this point here on the y-axis? What's our y-intercept? 7, yeah. So from the middle of the graph, we're going up 1, 2, 3, 4, 5, 6, 7. All right. How about our slope? Is this a positive or a negative slope, first of all? It's a negative slope. Yeah, it's going in a downward direction from left to right. So whatever our fraction is will be a negative number. Okay. How far down do we have to go? Close. 6, yeah. We're going down 6 spots, so it's a negative 6. So there's our negative. And how far over? How far over is that? 4. So plus 4. Because the run is always from left to right. So this run, this second number, is always going to be a positive number. So rise over run, we're going to have negative 6 over 4. Should we leave our fraction like that? No. All right, Liberty, how should we write that fraction? Negative 3 over 2. Nice. Because that reduces. Anytime you can reduce the fraction, reduce the fraction. These are each divisible by 2. Negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. If you want to use a calculator to plug in that fraction, you're welcome to do that. That would really be the only use of a calculator on today's lesson, but you are welcome to use it for that. So we're going to use this as our slope, negative 3 over 2. We're going to use this number here, 7, as our y-intercept. So somebody tell me, what is our equation for this line? Creighton? Yeah, that's it. Y equals negative 3 over 2x plus 7. Awesome. So we've got 8 more to go through. And I'm going to give you till 8:40. So that's 12 minutes to do these 8 problems. And I want you to try to work through as many of them as you can. You might notice that it doesn't give you a spot to write down M and B. So on number 9, I would say definitely write down what M and B are equal to. Just write them off to the side here. So write M equals and then have a B equals spot as well. Always have an M equals and a B equals. That way you can write those down first as opposed to just trying to figure them out and remember them and then just put them all in the equation. So have an M equals, a B equals, and then write your equations. And we'll check back in at 8:40. And please ask questions in the meantime if you need some help with these. All right. So let's go ahead and look at these 9 through 16 real quick. For number 9, we're going to take a look at our 2 points here. And we're going to count the vertical change first. So we're going to go up 2 first, and then we're going to go over 5, I believe. So I'm going to use a red pen just to highlight this a little bit easier. So that's plus 2 there, and then 1, 2, 3, 4 over 5. So plus 2 plus 5 for my rise over run. So my slope, M, is 2/5. And then our y-intercept, and I realize I went backwards from what I told you earlier in terms of which one to figure out first. It doesn't actually matter which one you figure out first. You can figure out the slope first or the y-intercept. And then the y-intercept is down here at 1, 2, negative 3. So we have a slope of 2/5 and a y-intercept of negative 3. So our equation will be y equals 2 over 5x minus 3. All right. The next one here, number 10. Number 10 has probably 3 different exactly correct ways to write this particular equation. So I'm going to talk about the y-intercept first because it's the slope that makes it possible to write different equations with this one. So our y-intercept B is at 1, 2, 3, 4, 5, negative 6. So B is at negative 6. And the slope from this point to this point here is up 5. So plus 5 and over 5, which is another plus 5. Now, 5 over 5, what's another way of saying 5 over 5? 1, exactly. Did anybody notice, and Miss Eddie, I'm going to go ahead and talk about the thing that you were mentioning. Did anybody notice on the graph itself that every single point in between could have had a dot on it in terms of like whole number XY coordinates? Did anybody see that? Like this point here is like a nice whole number coordinate. You know what I mean by a whole number coordinate, where it's like a perfectly like 1, -5, and then like 2, -4. Nice whole number coordinates. So every single one of these points is like right on a nice whole number coordinate, which means we could have just gone up 1 over 1 to get to the next point on that line. So if you notice there is another point in between the two dots that are on there, you can use that other point even if there isn't a dot. For example, we'll get back to this one in a second, but on number 11, does anybody see a nice whole number coordinate in between those 2 points? Do you see where the line crosses right through a whole number coordinate in between these 2 points? Absolutely, go ahead.
Okay. I usually tell the kids where it crosses at the corner.
Yeah. Yep, where those 2 grid lines, yeah, exactly. Where those 2 grid lines cross, if the line goes through one of those perfectly, that would be an excellent place to put another dot. So does anybody see where that happens? On this next one, in between these 2 dots, does anybody see on a place on this line where the line crosses 2 of those coordinate lines crossing each other? Sometimes it can be hard to see, especially if it's a diagonal line, but this point right here, yeah, like right in the middle of those 2 points. So when we get to number 11, there's a couple different ways that we can do this one. So there are some options here, because if you can find the closest one of those points, that means you won't ever have to reduce the fraction. So for example, if we went with 5 over 5, we would reduce that to equal 1 over 1, or just 1. But if you notice that you could just go up 1 and over 1, and then that line crosses through where the grid is, running right through itself. That also means you could just go up 1 over 1 and not have to worry about reducing the fraction at all. So if you notice that, you're welcome to do that. So the different ways that we could write this equation, we could say y is equal to 1 over 1 x minus 6. This is the way that I would recommend it. I'll move that up so you can actually see it. So you've got 1 over 1 x minus 6. You could also have written, I'm just going to write these on my sticky note because this is the one that I'm going to keep as the official answer. You could have also written y equals 1x minus 6. That works as well. You could have also written y equals x minus 6. And the reason why I bring this up is because sometimes when you are being told to graph a line from an equation, you will see them written like this third one here, or this second one here. And if you see this third one, you'll have to figure out that that has a slope of 1. Even though there's no number there, you'll need to know that that means this has a slope of 1 because x is the same as 1x, which is the same as 1 over 1x. So you will run into that. I'm just letting you know. But if you're writing the equation as opposed to being given the equation, I would say do this first one up here, 1 over 1x minus 6. All right, let's take a look at number 11. So number 11, we've got ourselves a y-intercept of, let's see, 1, 2, 3, 4, 5. So that's a y-intercept of 5. And our slope, m, is equal to, I'm going to go ahead and go between the 2 farthest dots first, and then I'm going to go between the 2 that are closer to each other, and we'll see how those 2 things compare. So to get from this first one to that one down there, it's down 2, so that's -2. And then 1, 2, 3, 4, 5, 6, 7 over 8. So down 2 and over 8. So -2 and a positive 8. So our slope is -2 over 8. But -2/8 reduces, right? What does -2/8 reduce to? What does that equal if we reduce it? Yeah, -1 over 4, or -1/4. Now, based on this point that we found out in between here, we can actually go down 1 and over 4. So down 1 over 4, we could have gotten that right away. If you spot this point in between, you can use that, -1 over 4, instead of -2/8 and then reduce it. So there is a way that you can do these without ever having to reduce your fraction if you find those points on the line that might be in between the two dots that you're given. Number 12, though, do you see how on number 12 we don't have that option? Can you see how on number 12 the option doesn't exist to put another point in between here that's on like the intersection of the grid lines, right? Because it doesn't go through the corner. It doesn't go through the corner of where two of those lines cross. It just kind of aimlessly goes through some of these other points. So that actually means we're not going to be able to reduce this fraction to begin with because those are the two closest points. So our y-intercept this time, b is equal to 0. And our slope from here to here, we're going to go up 1, 2, 3, 4. So +4. And then 1, 2, 3/3. So we have a slope m of 4/3 or 4/3 and a y-intercept of 0. So we're going to have y equals 4/3x plus 0. The other way to write this would just be y equals 4/3x. Because plus 0 doesn't really make a difference in terms of how that ends up looking. So that's what we've got for those ones. Any questions there before we continue? Oh, you're right. On number 11, I didn't write the equation. Y equals -1/4x plus 5. Cool. Yeah, thank you for reminding me. Appreciate that. Okay, 13. So number 13, do we have a positive slope or a negative slope on number 13? Is this line going up or down? Anybody? I know you know it. We're just tired. I get it. Down. All right. So negative slope. The y-intercept is at 1, 2, -3. And this is a pretty big gap between those 2 points. Do you see where this line might cross 2 of those grid lines, like right through the corner of them? Yeah. Where at? Where at? Down here? Oh, right here? Or right here? Yeah, it's every 2 boxes, isn't it? Like every 2 boxes. So if you go, there's one right here. That's one. There's another one here. There's actually quite a few. We got one here. So this line goes through a lot of different places, and we can actually go outside those 2 lines too to figure out our slope. So to get from any one of these points to any other of these points, what are we doing? How far down are we going? Let's just say we're trying to get from one to the next in terms of ones that are right next to each other. Like from, let's just say from here to here. How far down, how far over? That's down 2. So -2. How far over? 1. So our slope is -2/1. I think the original one was down 8/4, right? The 2 points that were given on the graph to begin with. I think it was down 8 and then over 4. But down 8/4 reduces to -2/1. So it ends up being the same either way. So I'm going to say just, pick these 2 that are close to each other. That way we don't end up having to reduce anything from the original. And so we get y equals -2/1 x minus 3. Cool. Now on this next one, this is where this strategy right here that we used on number 13, we have to be really, really careful about it, because on number 14, it looks like we might be able to use that strategy again. However, we can't. And I'm going to zoom in a little bit further just to show you. Like it gets super close to going through the corner, but it doesn't ever actually end up going through the corner of any of these. It looks like it might happen right here, but it's just below the corner of it. So when the graphs are small like this, sometimes it can be hard to tell. Does it go through the corner of those 2 grid points or does it not? If you are unsure about that, just use the 2 points that are furthest away, figure it out, see if it reduces. If it does reduce, that means that yes, there was a point in between. But if it doesn't reduce, like on this one does not reduce, it means that these are the 2 points that we have to use because there aren't any points in between where the line goes through the corner of 2 of those lines. So on this one, we've got here to here, we're going down 1, 2, 3, 4, 5. So that's a -5 here. And if the graph was actually like physically larger, we'd be able to see that a little bit clearer. But sometimes when the graphs that are on the paper are so small, it can be hard to tell. Does it go through the corner or not? We don't know. Then we're going to go over 1, 2, 3, 4, 5, 6. So down 5 over 6. So that's a -5 and a +6. That does not reduce when we make it a fraction. So our slope, m equals -5 over 6. The y-intercept is up 1, so b equals 1. So our equation then is going to say y equals -5 over 6x plus 1. Oh, wrong way. There we go. All right, 2 more to go. Now this one does end up giving us an in-between point. I'm not going to use it on this one though. I'm just going to go with our furthest ones away. So we've got m and we've got b. The y-intercept here is at -2. Our slope, we're going to go up 2, so +2, and over 1, 2, 3, 4, 5, 6, up 2 over 6. So 2 over 6 reduces to equal 1 over 3. So 1/3 for our slope there with a y-intercept of -2. So we're going to say y equals 1 over 3x minus 2. And our last one, number 16, our y-intercept b is equal to, let's see, 1, 2, 3, 4, 5, 6, 7, 8. It's up at 8. That's where that line crosses the y-axis. And the slope, if you found an in-between point, great, feel free to use it. I'm just going to count the entire thing this time. So I know that from y down to here is 8. And I've got 2 more to go, so that's 10. So that's down 10. So -10, and then over 2. And this one does reduce, which means there is a point in between them. So we get m equals -10 over 2, which equals -5 over 1. So if we go down 5 and over 1, there's another point in between here, and it's right here. All right, so our equation is going to be y equals -5 over 1 x plus 8. And that is it for today's notes. I'm going to get you the assignment, like I said.